Good afternoon, all of you. We are going to continuing our physics class 10 physics. Okay, last time we were discussing sound, so we will continue with that sound. And the topic we were discussing was echo. Today's date is 10th August 2020. In the last class, we have already discussed briefly what echo is. Echo is a reflection of sound after it strikes an obstacle. So suppose we have a source of sound here and we have one obstacle here. Okay, then what happens is the sound travels, hits the obstacle, and it returns. So in this way an echo is produced. The echo is produced after the original sound has ceased or stopped. So from here we have got the formula, which is 2d by t. So this was the formula. This d is the distance between the source and the obstacle. The t is the time taken by the sound to travel, hit the obstacle, and come back. Now, you're continuing with this. We will do some numericals from a textbook on page number 153. So let us do some numericals today. These numericals are very important from the exam's point of view also. If you turn to your textbook, physics textbook, we have numericals in page number 153. There are about 10 questions, so I'm going to solve only 5 today. Question number 2. Let me read question number 2 here. It is given, the question is like this. You calculate the minimum distance required between the source of sound and the obstacle to hear an echo. It is very easy numerical. There is a source of sound. Suppose this dot, I make it as a source of sound, and the obstacle. Let us make this another dot as obstacle. We have to find the minimum distance, that means d. So let us start here. Given, if you look at the question, take the speed of sound in air as 350 meter per second. So the speed of sound is given to you 350 meter per second. Now here the time is not given to you, but we know that in case of the echo, the minimum time which persists for an echo to produce is 0.1 second or 1/10 of a second, 1 by 10. Now it is very easy. We have to find the distance. For that, we can solve the side. We have already learned that velocity equals to 2d by t. This is the formula which you have used for an echo. Now we have to find this d, the distance. Alright, so you can, after doing cross multiplication, we get v into t upon 2. So this t will go here and v, so there will be a cross product or cross multiplication. Now simply you substitute the value of velocity 350 time 1 by 10, and this 2 is given to you. This distance will come in meter. So after cancelling, we have got your 35 by 2, that will be 17.5 meter. So this is the minimum distance required between the source of the sound and the obstacle to hear an echo. Okay, so keep one thing in mind. In the echo you have got only one formula. V, that is the speed of the sound which is traveling in the air. D is the distance between the source of the sound and the obstacle. Time, the minimum time required for the sound to return back to the source. Okay, now we go to another question in the textbook. It is same, page number 153. Let us see question number 5. Okay, now question number 5 is also similar. In fact, all the problems related to this echo is similar. Look at question number 5. A radar sends a signal to an aeroplane at a distance 45 km away with a speed of 3 into 10 to the power 10 meter per second. After how much time is the signal received back after reflecting from the aeroplane? A radar sends a signal to an aeroplane. So let us say we have this aeroplane here, and from the ground there is a signal sent here. Okay, so it is in the form of sound. So what is the distance? Distance between the radar and the aeroplane is given to you 45 kilometers. See the unit, it is in kilometer. Then this radar is going at a speed of 3 into 10 to the power 8 meter per second. That means it is traveling at the speed of light. Now, after how much time is the signal received back? So you have to calculate the time. Now we have already learned that the formula is V equals to 2D by T. Now, again, after doing the cross product, since we have to find the time, so we can cross product like this. V will go down, time will come up. Now you substitute and calculate the value of time. Distance is given to you 45. If you look at the unit of the distance, it is kilometer, but the speed is in meter, so this kilometer needs to be converted into meter. So we change it. 1 kilometer is 1000, that is 10 to the power 3. 1000 means 3 zeros. And the speed is given to you 3 into 10 to the power 8. 3 15s are 45. So after multiplying, you get 30. Then here you have to use the exponent law. The base 3 minus 8 is minus 5. This is the answer. Or you can also write like this. If you remove 1 0 from here, 1 0 will be less here, so it will be 3 into 10 to the power minus 4 seconds. So after this much time, very less time, the signal is received from the aeroplane and it is back into the station. So here this formula is the key. Likewise, we can do another question also. So let me complete 2 more questions here. Now I am going to drop this and I am going to go directly to question number 9 in your textbook. Please look at question number 9 in the textbook. This question is an ICSE question. Make a star here. It had come in ICSE. It may come again. A person standing between the 2 vertical cliffs produces sound. A person standing between 2 vertical cliffs produces a sound. 2 successive echoes are heard at 4 seconds and 6 seconds. Calculate the distance between the cliff. So let me draw the 2 vertical cliff here. Let us say this is one cliff and this is another cliff. So we have 2 vertical cliff. In between these 2 vertical cliff, there is a person standing here. Okay. Now this person, suppose he faces to the cliff one first and he makes a sound, then he hears the echo after 4 seconds. So let us take the first case. Let the distance between the person and the cliff one be x. Okay, the speed of the sound we do not know, we have to find that. We have to find the distance between the, calculate the speed, calculate the distance between the cliff. Okay, so now time taken for the echo to be heard is 4 seconds. So let us